So we are solving the same question using Excel. I'll read again what was given in the question. Marilyn purchased a mailing list of 20 names and addresses from her mail order business. But after scanning the list, she doubts the authenticity of the list. If 40% of the names on the list are non-authentic, we have to calculate probability of selecting exactly 10 non-authentic names in her sample. So it's a binomial experiment. We have two possible outcomes: to be a non-authentic name, and this is considered a success, so P is decimal 4, and the other possible outcome is to be authentic name. This is considered a complement probability here, so it will be decimal 60. The number of names on the list is 20, so the number of trials N is 20. We are looking to calculate probability to have the number of successes to be non-authentic, exactly X. So we are going in functions, insert function, statistical function, and I'm looking for binomial distribution. X in our situation is 10, the number of trials 20, probability is decimal 4. It's not a cumulative probability. I'm looking just for one probability when X is exactly 10, so it will be false. And we can see the probability. So probability is 11.71. I'll write it down here. Similar, we go in function, binomial distribution. For part B, we are looking to calculate the probability of selecting at least 2 non-authentic names in her sample. Again, at least 2 means 2, 3, 4, 5, up to 20. It's easier to calculate as 1 minus probability to be less than 2. That means what? Can be 0 or 1 non-authentic names on the list. So, similar here. We are going N less than 1. Number of trials, 20. Probability is decimal 4. And we are looking for cumulative. Yeah, can be 0 or 1. So in this case, it's true. So this probability is decimal 0.05. But again, the real probability, because we are looking to be greater or equal to and not less than 1, will be 1 minus this value. So this is our probability. If we express as percent, will be 99.95%. So again, to calculate probability to select at least 2 non-authentic names, we can write as 1 total probability minus probability to be less than 2. Less than 2 means 0 non-authentic names or 1. And when we calculate it with binomial, so we put 1 for number of successes, because we are looking to be cumulative, can be 0 or 1. The number of trials 20, and we put here true. We are looking for part C to calculate the probability of selecting 5 or fewer non-authentic names in her sample list. So again, we are going in insert function. We are looking for statistical binomial distribution. So the number is 5 or less than 5, trials 20. We have probability decimal 4, and it's true because it's cumulative. Can be 5, 4, 3, 2, 1, or 0. And this is the probability. If we express as percent, so it will be 12.56%. What is the average or expected value of non-authentic names in her list? Once more, the expected value for a binomial experiment is the product between the number of trials and probability to be considered a success. So if we want to have the expected value for x here, I'm going in formula bar, I'll type equal n times p. So the expected number of non-authentic names on her list in average we expect to be 8. If we are looking to calculate the standard deviation is square root of the product between n, p and q. So I'm going in formula bar, will be n times p times q. I'll close my bracket, a power 1 divided by 2 to be square root of. So this is the standard deviation. So on a long run or in average, we expect to have 8 non-authentic names on the list, plus or minus 2.19.